In the second video in this series, I showed how we can use new raster overlays to visualize categorical datasets in Climate Engine. Today, we're taking that a step further by using these same datasets as data masks for time series data, so that we can focus our graphs on exactly the areas that we care about on the landscape and directly compare how different places behave. For this example, we're going to look at land surface temperature time series in Chicago based on different developed land cover classes from the National Land Cover Database, NLCD. Let's start by zooming in on Chicago and visualizing NLCD in the map. We can see medium and high intensity developed zones in the city center and low intensity zones in the suburbs. Higher intensity development generally means more impervious surface, while lower intensity development includes more vegetation. To orient ourselves to the area, I'm going to first make a map of mean land surface temperature during June, July, and August of 2025, and we can clearly see that surface temperatures are higher in areas with more impervious surfaces. But let's take this analysis a step further and pull data by development type in the Chicago area. First, I'm going to define the Chicago core-based statistical area from the US Census as my region of interest using a shapefile. Then I'm going to set up my form to extract land surface temperature values from Landsat 5, 7, 8, and 9 during the last year. The new functionality compared to the earlier videos is the optional masking section of the form. Here, we'll use the mask data by category option to compare surface temperatures in low intensity development as variable 1 to medium and high intensity development in variable 2. Once I click Compute Time Series, I'll receive a line plot with two lines for land surface temperatures across the two development patterns. Notice that the caption is used to indicate which line is which. If I zoom in on the summer period, we can see that higher intensity development patterns also have higher surface temperatures in the Chicago metro area, often by 4 degrees Celsius or more. That's a clear quantitative example of the urban heat island effect. There are many new ways that this new functionality can be used, and we're excited to highlight these use cases. For example, in addition to land cover, we can use land ownership or wetland layers to further refine our analyses, and in the coming months, we're looking at adding many new layers. We'd love to hear from you as you start to use this new functionality, and let us know your requests for new masking datasets in Climate Engine. Thanks for watching.